vine mealybug can destroy generations of success. Fight back with the mating disruption more growers trust. Visit sutera.com/VMB.
Hello, I'm Matthew Malcolm with American Vineyard Magazine, reporting to you from Fresno State Grape Day. Happens every other year. It's great to be here. I'm here with Luca Berlante and Kayla Vasquez. They've been working on some aerial imagery projects just in the vineyard to understand and better measure water stress. And wanted to talk with you about that. What are we learning? Obviously, we're trying to automate as much as we can because there's too much to do and never enough time, right? Or enough labor to help catch these things. So what can you tell us?
Yes, we try to be more efficient into optimizing the use of resource because there is not enough water, and we will be always more limited into the way we can use that water given the current regulations. So it's important to make agriculture viable, to try to be mindful of how we apply that water to make the most of what we are allocated. And so we're trying different things, from the use of satellites through the use of drone imagery. And we have been working in the past with thermal imagery, which is very common, and you have multiple companies offering service, a very useful service for growers. And of course, in the research and the science, we always try to test new things. And in this case, we are assessing hyperspectral imagery into the near infrared, which is way beyond the light that we can see, and but it's very important into assessing water because it's a region which is very responsive to the amount of water into the plants. By using this information, we think that we can optimize irrigation, and then we have combined the trials with some automation of irrigation at the hose level, and so we have created multiple irrigation zones into the same field, and so we try to manage irrigation scheduling, 16 different treatments, 16 different irrigation schedules in the same field, automated through the use of drone technology and Internet of Things.
Yeah, I don't know if you can see it through the camera, but we've got this nice drone they've been working with right behind us. Kayla, can you tell us a little bit more about that and the project?
Yeah, so I am the one who does most of the acquisition of the data that we use. One of the major things that we are trying to do is achieve practical progress, so trying to see what the grower needs as far as workflow and how we can achieve that, and our goal of maintaining sustainability. So I think something that's really important in the whole scheme of this is building a workflow with these new tools and developing tools and finding a way to bring them into the vineyard and actually be useful and practical.
So what's your practical application for this?
Well, we're finding out what that is every day, right? So that's the biggest part of research is finding the best fit solution and or an adaptive best fit solution. So every day we're learning how we can be more efficient in our acquisition, as well as processing the data and being able to actualize it into a sort of recommendation for the grower. And so we're not at that point yet, but that is the primary goal, is to meet the needs of our California vineyard growers.
Now, with water stress in the vineyards, you really want to catch it before it's too late as far as having an impact on the crop, right? So how fast of a turnaround are we talking about with this, the aerial imagery and being able to get an analysis in the field?
So currently we acquire information on a very large area of the light spectra, and that's what we call hyperspectral, and so there is some processing time. And that's what the work is. Try to compress and reduce that information so that it becomes actionable. And ideally, we would like to simplify the sensors that we use, and everybody can fly a drone. So, and then these sensing systems can also be mounted on airplanes, and so can also enter into the services already offered by companies to growers, and being readily available. And so in the end, transforming some sort of very strange data into one which is very common. So we translate hyperspectral imagery into pressure bomb information. So the growers ideally will try to fly or acquire that image, and instead of having an idea of crop water stress index or a red stressed area, they will actually have a number which is minus 12 bars, minus 15 bars. And so a number that they are used to, that there is a lot of information on it, on what is the impact on the plant physiology, and act as a consequence of that number.
Right, and we certainly don't want to have data overload, with all this, automation. So as far as translating that, I think is critical in a way that can be understood and know what to do with it. So if you have a segment that you're seeing is experiencing a lot of water stress, how do you apply that?
Yes, and so that's why we combine these. We're working with a company which is called Verdi Ag, which is collaborator on this project. They automate irrigation at the hose level, and of course there are other companies automating irrigation at the block level. Yeah. And so, of course, for us was easier working at the hose level because it's smaller size of a trial, so we don't risk to lose for a bad decision 50 acres all at once, but only a few tens of vines. And but we are actually applying different amounts of water through a computer from Fresno in a vineyard which is in Cantua Creek.
Nice. Well, hey, thank you guys for the good work that you're doing. This is one of many projects that you're working on here at Fresno State. Read more about these things in American Vineyard Magazine. I'm Matthew Malcolm, CaliforniaAgNet.com.